All right. So I wanted to give you a brief demonstration on project 2, which is all about the Pythagorean Theorem. There are 3 tasks that I want you to perform for project 2. So you're going to create 3 different sketches in an online software called GeoGebra. Here I have a link to a video that will show you how to create a right triangle in GeoGebra. So you can watch that one in addition to watching this one if you feel like you need more clarification. And then the link to GeoGebra is right here. So you can click on this link and it'll take you to GeoGebra. But I also just want to show you real quick, if you were to just go to, so this is going to take you to the part of GeoGebra that I want you to look at. But if you were to just type into your address bar, GeoGebra.org, then it's going to take you here. And GeoGebra is really cool. They have all kinds of like graphing calculators, 3D graphing calculators, right? It's pretty nice. But if you want to go to that GeoGebra Classic, right, then you need to click on GeoGebra Classic down here. And then that'll take you to the same place. So that's another way to get to GeoGebra. So let me show you how to do a couple things in GeoGebra so that you can complete the project. First of all, notice that the arrow up here is highlighted, and so that means that I have, that's called the select tool. So I can select stuff and I can move the axes around and all of that. If I want to create a shape, so your first task is to create a right triangle. So in order to do that, I need to make sure I need to make sure that one of the angles is a perfect 90-degree angle. So you could try to kind of do that by hand, you know, by selecting a polygon and trying your best to create like a right triangle. But then try as you might, that's probably not a perfect right angle. And in fact, we can measure that angle. So if we use this tool right here, this is our measurement tool. You can measure angles, you can measure distances or areas. So if I wanted to measure this angle, then I would now, it says, and this is really nice because when you click on something in GeoGebra, it tells you how to use it. The message just disappeared, but it said select 3 points. So I'm going to select these 3 points. And you see it's not quite 90 degrees. So trying to do this just freehand, trying to create a right triangle freehand is probably not the best bet. So I switched back to the select tool so that I can select this triangle, and then I'm just going to hit delete on my keyboard to get rid of it. Oh, I guess I could. Another way that you can delete these things is over here in the input bar. You can delete them from there as well. So here's a better way to create a right triangle. So what you're going to do first of all is give yourself a line segment. So if I click over here, these are all of my line tools. I can create a straight line, or I can create just a segment of a line. That's what I want to do first. So I'm going to create a segment, just any old segment. And then I'm going to click on this tool right here. This allows you to draw a line that's perfectly perpendicular or parallel, or that bisects another line, or whatever else, right? They have all kinds of good stuff here. But I want to create a perpendicular segment. So I'm going to click on the perpendicular line tool, and you see down here it says select point and perpendicular line. So I'm going to select a point, and then the line that I want to draw this new line perpendicular to. And you see now it gives me this straight line, and this line is perpendicular to the segment that I drew. It's perfectly perpendicular. And in fact, I'm going to go back to the move option. If I move this point around, see, the whole thing moves with it, and it preserves that 90-degree angle, which is perfect. That's exactly what I want. So now to create a triangle out of this, I'm going to go over here and select this. These are all my point options. So I'm going to put a new point somewhere on this line, and then I can create another line segment going from this point to this point. And then I've got my right triangle. Of course, it's kind of messy to have this this full line kind of extend all the way through the triangle. So to get rid of that, again, I'm going to select the move option so that I can select this line, and then I'm just going to hit delete on my keyboard. That's not what I wanted to do. That was a mistake. So I'm going to undo that. Kind of nice that you can undo mistakes. I don't want to do that. I guess what I want to do is just hide this thing. So if I right click on it, now I get all of these options here. I don't want to delete it. I just want to hide it. So I'm going to say, no, don't show the object. There we go. That's a little better. And now I can create a segment going from C to A. No, not a line. I just want a segment going from C to A. And now I've got a really nice right triangle. Now I want you to prove to me that this is in fact a right triangle. So I need you to measure this angle so before you submit this object, I need you to measure the angle. So I'm going to use my measurement tool again and remeasure this angle. And this time, sure enough, it's exactly a 90-degree angle, right? You can kind of move the labels around if you want to make it a little more clear. But yeah, now you can see it's exactly a 90-degree angle, which is nice. And it remains a 90-degree angle no matter how I move around the triangle, the figure. It stays 90 degrees. Now that's just part of what I want you to do for your first task. The other thing that I want you to do now is verify the Pythagorean theorem. Now what does the Pythagorean theorem say? Well, it says that leg squared plus leg squared equals hypotenuse squared, right? So what I need to do is measure each of these sides, right? I need to measure the legs, and then I need to measure the hypotenuse, and then I'm going to create an input line over here to show that leg squared plus leg squared equals hypotenuse squared. So let's start off by measuring these things. Again, I'm going to go to the measurement tool. I'm going to click on distance. And then all I have to do is select 2 points or select a segment. In this case, I'm just going to select the segment, and it measures it for me. That segment is 5 units long. This one is 4.86 units long, and this one is 6.97 units long. Those measurements will still change when I move my points around. You see? Now that all by itself doesn't prove the Pythagorean theorem. What I need to show is that this squared plus this squared equals that squared. So over here in the input line, I'm going to do I squared. So I'm going to type I caret 2. So that's I squared. The caret button is above the 6 on your keyboard. So you'd hold down shift and then hit the caret button, and that gets you into an exponent. So that's I squared. Now I arrow over, and then I'm going to say plus. I want the other leg, so that's F. I'm going to say plus F squared. And then it gives me that answer. That's 94.63. Now to show that that's the same thing as H squared, I'm going to type in H squared down here. H squared equals. And sure enough, right, H squared is also 94.63. And again, these things will change when I move the figure around. So if I take this point and start dragging it around, notice that these numbers change, right? But they're still equal to each other, which is good. That verifies that the Pythagorean theorem is true, right? No matter what I do to this triangle, the Pythagorean theorem still remains true, right? Leg squared plus leg squared is hypotenuse squared. Okay, so that's task 1. Task 2 is to show a more geometric interpretation of the Pythagorean theorem. So for task 2, I want you to create a new picture. It's also going to involve a right triangle though. So I'm going to be a little bit lazy and I'm not going to actually create a new one. I'm just going to hide a bunch of these things. No. Just want to hide the measurements. I want to show that object. I swear there's a way to do this. label, right? So I don't want to see the labels necessarily. Anyway, so here's my right triangle again. So pretend that I did this all over from scratch. Okay, now what I want you to do for task 2 is I want you to mount some squares to each of the sides of the triangle. Because the Pythagorean theorem says leg squared plus leg squared is hypotenuse squared. In other words, the square formed by one of the legs, right, the area of the square formed by one of the legs, plus the area formed by the squared of the other leg, equals the area formed by the area of the square formed by the hypotenuse. So to see if that's true, let's mount some squares to each of these sides. So I'm going to come over here to my Polygon tools, and I don't want to select polygon. I want to select regular polygon because this has to be a square, so all the sides have to be equal in length. So the easiest way to do that is to select the regular polygon tool. I'm going to select that, and now down here it says select 2 points, then enter the number of vertices. So so if I want to mount a square to this side, then I'm going to select these 2 points. And then a little dialog box comes up and says, how many vertices do you want? Well, for a square, I would want 4 vertices, right? So I'm going to say 4. Oh, and that went the wrong way. I want the square to open out in the other direction. So I'm going to delete this one and try again. I selected the points from C to A the first time. If I go from A to C, then this time it should open the other direction, which is the way I want it. So sometimes this is a little trial and error. And I should mention, the same thing's true when you're trying to measure an angle. So let me just show you that real quick before I do the rest of it. So I'm going to delete this. Okay, when I measure an angle, so I need to use my measurement tool. If I go in this order, notice that it's giving me the outside angle there, and it's telling me that outside angle is 270 degrees. But that's not the angle that I wanted to measure. I wanted to measure the inside angle. So, so I'm going to delete that one and select the points in the opposite direction. So before I went C, A, B, now I want to go B, A, C. And it gives me the angle that I'm looking for. So anyway, the moral of the story is sometimes you have to play around a little bit to get to make sure that you're selecting the points in the order so that you get the kind of picture that you want. Anyway, so this is now a square mounted to this side. I could do the same thing for the other sides, right? So I could mount some polygons here. Hopefully this goes the right way. And a polygon here, or a square here. Wrong way again. Let me try one more time. This square. Okay, and then I'm going to zoom out. So over here down at the bottom left, you have, zoom in, zoom out. So I'm going to zoom out a little bit, drag this over so it's more centered. Okay, so there's so there I have my triangle with squares mounted on each side. Now, the Pythagorean theorem says that the area of this squared, the area of this square plus the area of this square should equal the area of this square. So to verify that, I need to measure these areas. So I'm going to go to my measurement tool again. This time I don't want to measure a distance or an angle, I want to measure an area. So I select that. And then I just select the polygons that I want to measure the area of. Now that all by itself doesn't really do anything. It's nice that the areas also change, right, accordingly when you change your figure, but it doesn't show us that this plus that equals that, unless you had a calculator and you could verify that. So I'm going to use the input line over here again to verify that thing. So I'm going to say this was called poly 1, this was called poly 2. So I'm just going to type in poly 1 plus poly 2 and hit enter, and then it adds those areas up. And sure enough, when I add poly 1 plus poly 2, I get 125.74. which happens to be the area of poly 3. And again, that's going to change whenever I move this triangle around, right? So that's task 2. So I've basically done the project for you. I've done the first 2 tasks for you. I need you, of course, to do your own version of this. But then task 3. Now, task 3 is to redo task 2, but using a different shape from a square. So instead of doing a square, do like a triangle, or you could do a semicircle, or you could do a hexagon. So a hexagon, for example, again, we would select 2 points and then enter the number of vertices. For a hexagon, I would want 6 vertices, right? Keep doing that. Let me get it to go the other way. So a hexagon, 6 vertices. Right? So I could mount that hexagon there. I could mount another one on this leg and another one on this hypotenuse. I could use the measurement tool to get the areas of those 3 things. And then in the input box, I could say poly 1 plus poly 2. And hopefully that equals the area of poly 3. Then again, maybe it doesn't. I don't know. I'll leave it up to you to see if the Pythagorean theorem is still true for shapes other than squares. So anyway, but that's that. That's all I'm going to show you for task 3. So I think I've shown you enough. You can figure out the rest of task 3 on your own. But that's project 2.